Ahoy, mateys! In this lesson, I'll be teaching you more about the standard normal curve and how to use the normal chart to help you solve problems involving areas under the curve, probabilities, and percentages. Now, we've been talking about the 68, 95, 99.7 rule to help us approximate certain areas on the graph. With the table, we can get much more specific and exact in our calculations. So, we'll have standard normal calculations, and there'll be questions involving what proportion or percentage of observations lie in some range. Now, sometimes you'll see it worded as a probability. It basically means the same thing, you just don't have a percent on it. So we'll find the area under the curve like we've been doing. Now, after we find the z-score, we standardize that score, and basically we turn all graphs into a similar graph, which is the standard normal curve. We can use one table to find the areas. So we have a standard normal table that is in the front of your book. It's table A in the front of your book, and it gives us the areas under the curve to the left of each z-score. So you've got your normal curve, symmetric, single peaked, has a mean of 0, standard deviation of 1, and then here we've got some random z-score. Well, if I want the shaded area to the left, I can basically look this z-score up in the table, and it will give me that area. It's very convenient. It saves us a lot of time when estimating, so we don't have to estimate. So I'll give you some practice problems first. So here we go. Let's say I want to find the proportion of observations that are less than 1.98 standard deviations. So that's like a z-score. So first thing I'm going to do is I'm going to draw a picture. Right? We start to draw some pictures to help us visualize what's going on. And it also is required for full credit. Now remember I said the mean would be 0 according to the standard normal curve. And here we've got 1.98. It says the proportion of observations less. So less means to shade to the left. Okay, I'm looking for that area. Now, we would have estimated this in the past. Now we're just going to look this up in the table. How I write my answer is like this. P stands for the probability, or you can think about it as proportion, that Z is less than 1.98. Now, I'm simply going to look this up in my table. Now, you'll need your textbooks to follow along. It's right in the front of your textbook. You can't miss it. You open up to the very first page. Okay? And it looks like this. Now, this is kind of an overview. I'll zoom out here so you can kind of get a better idea of what's going on. This is 2 pages. It's a photocopy of it. You got all this information here that soon you'll be pros at, and right now you don't, it looks like a whole bunch of numbers that don't make any sense. So, on the left here, you can see Z, and you've got a lot of possible Z-scores. Negative 3.4, and then as these get bigger, they get to 0. That's the middle of the graph. And then we flip to the right page, which is all the positive sides. So here the z-scores get bigger and bigger and all the way up to 3.4. And they actually go to the hundredths, 9. So these numbers across the top are the hundredths. I'm looking up a z of 1.98. So again, I did some calculations. I got a z-score of 1.98. I'm going to look that up in the table. So it's positive, so I'm going to go on the right side of the table, on the right page, and I'm going to go and I'm going to find 1.9, and then I'm going to go over until I get to 8. Okay, I'll zoom in a little bit more so you can see it. So again, here's 1.9. I scanned down, I found 1.9, and then I'm going to go over until I get to 0.08, which is, again, 1.98. And I get an area of 0.9761. This area right here, 0.9761. So I come back over here, and I get 0.9761. That's my answer. That's the area of this black shaded part. Now, as a percentage, it'd be 97.61%. As area, it's 0.9761. Remember, the whole thing adds up to 1. And as a probability, it's 0.9761. So all different terms that you will be asked to report back this type of information. Okay, number 2. Find the proportion of observations that are less than negative 2.23. So again, 0's in the middle. We got negative 2.23, and I want less. Shade to the left. Okay, I can see now that that's a much smaller area than in the last one. So again, I'll write that as probability that C is less than negative 2.23. I have a table that will tell me the answer, basically. It will tell me the area to the left of negative 2.23. So I go to my table, and I'm looking for the negatives first off. Okay, so I'm going to scan down here and find the negatives. I'm looking for negative 2.2. And again, I'm going to go over to the 3 column. So again, negative 2.23. 0.0129. Okay, right here, 0.0129. So that area is 0.0129. Now, that's again about 1.3% if you want to think about it. And that number makes sense. This is a small area here. So a very small percentage or area makes sense with that. And that's why I like the graphs. I mean, you got to do them to get full credit, but it helps you understand. Like you can see here that should be a big number. You can see here that should be a small number. Okay, going to the left's easy. Let's go to the right. Find the proportion of observations that are above, okay, negative 2.60. So again, there's my one. Negative 2.6 is way down here. And it says above, so I'm shading to the right. Now, as mentioned before, the table is only going to give me the area to the left. Well, that's a bit of a problem. Not too big of a problem, but it's a little annoying. So if I look up negative 2.6, okay, negative 2.6, I get 0.0047. 0.0047. Negative 2.60. Right here, 0.0047. Just draw a box. Makes it easier to see. 0.0047. So this little area here is 0.0047. Well, I don't want that area. I want the area to the right. Well, it would help if I knew what the total area was. I do. It's 1 minus 0.0047. So the probability that C is above greater than negative 2.60 is 1 minus 0.0047, which is 0.9953. And that, again, backs up my graph. I come over here and look at my graph. This is a big shaded area. So this 0.99 makes sense here. 0.04 or 0.0047 doesn't make sense for this red area. That's why I have the graph. It really helps me out. Okay, that's to the right. Now, in between. Okay, so I've got between negative 1.42 and 2.32. I want between. Okay, so these are the trickiest ones, really. Basically, what I'm going to do is, if I were to shade this whole thing, okay, if I look up 2.32 in the table, I'm going to get that whole shaded area. So I'm going to go ahead and do that real quick. 2.32, right? 2.32. So I go to the positive side, and I'm going to scan down here until I find 2.3, and I'm going to go over to 2. I can't really fit it, but 2.3012. It's that number right there. Okay, 0.9898. So this whole area is 0.9898. That's not what I want. I don't want less than 2.32. Now, if I look up 1.42, I'll get this shaded black area right here, or negative 1.42. So I'm going to look up negative 1.42. Okay, negative 1.42. Okay? Here, and then, again, 0, 1, 2. Follow that down. There is negative 1.4, 0.0778. Okay? So this little area here is 0.0778. I don't want that area though. I want kind of what's left over after I subtract that area away. That will give me what's left here. So I'm basically going to take 0.9898 and subtract 0.0778. Right? And again, how I write this is probability. This one's a little tricky. 4.2 less than z less than 2.32. And that's basically saying the probability that z is between negative 1.42 and 2.32, and I get 0.912. Okay? And again, that's taking this whole shaded area here and subtracting off that piece. So if I subtract that off, then I get kind of what's left over. Okay, so here's some problems that I would like you to try on your own. So there are 6 problems. I want you to find the area under the curve for each z-score. And remember to sketch a diagram for each problem. So go ahead and pause the video and use your table to answer those questions, and then unpause it and come back and check to see how you did. Good luck. Okay, so there are your answers with some kind of quick sketches. Again, we'll get into more of that. But for right now, that's an overall basis of how to use the table.